The question is, a polynomial is given and that polynomial is x to the power of 4 minus 27 x square plus 121, and this polynomial can be factored in unique way into a product of two quadratic polynomials with integer coefficients and leading coefficient of 1. What is the sum of the two polynomials? The points to note here is that the leading coefficients are 1 and the product is of two quadratic polynomials. So, the given polynomial is x4 minus 27 x squared plus 121, and this should be the product of two quadratic polynomials. The general equation of a polynomial that is quadratic is x square with a coefficient of a plus bx plus c, and if you take another such general quadratic polynomial, we get dx square plus ex plus f. Now, this is one quadratic polynomial, this is another quadratic polynomial. If we multiply both of them, we should get the given polynomial of the fourth order. That is ax square plus bx plus c multiplied by dx square plus ex plus f should be equal to x to the power of 4 minus 27 x square plus 121. Now, in the question, it is also mentioned that the leading coefficients are 1. Now, what are the leading coefficients? A is one leading coefficient and D is another leading coefficient. So, we get A is equal to 1 and D is equal to 1. So, our equation becomes x squared plus bx plus c multiplied by x squared plus ex plus f is equal to x4 minus 27 x squared plus 121. Now, let us multiply the left hand side. There are two expressions, we will multiply them. So, I will first multiply with this x square to get x to the power of 4 plus e into x to the power of 3 plus x square plus fx square. So, then let us multiply by bx, the whole expression on the right hand side. So we get bx cube plus e into b x square plus f into b x. Then finally, let us multiply with c. Then we get cx square plus e into c x plus cf. So this is the multiplication of the two factors on the left hand side, and if we add them up, we get x to the power of 4 plus b plus e x to the power of 3 plus eb plus f plus c into x squared plus ec plus fb x plus cx, and that should be equal to the given polynomial x to the power of 4 minus 27 x squared plus 121. While we are doing the multiplication, we have written down the product in a particular way so that the even powers of x are one below the other. That means x4, there is no other x4, so there is nothing on the second and third row. X cubed, there are two such terms which are one below the other. Similarly, x square, x and the constant term. By comparing the coefficients of like powers on both sides of this equation, we get, well, x4 here and x4 here both have coefficient of 1, so there is nothing to compare, but here this should be equal to 0, because on the right hand side there is no cubic term. So we get b plus e is equal to 0. Similarly, by equating the coefficients of the x square term, we get eb plus f plus c is equal to minus 27, and by equating the coefficient of the x term, we get ec plus fb is equal to 0, because on the right hand side there is no x term. Finally, by comparing the coefficients of the constant terms, we get cf is equal to 121. Let us call these equations, give a name to the equations. This is equation 1, let us say. This is equation 2. This is equation 3. And this is equation 4. Now here the variables are b, e, f and c. 4 variables. And how many equations involving those variables are there? There are 4 equations. Now the principle is, if you have got 4 independent equations for 4 variables, then we should be able to solve it. Let us now go ahead and solve it. From equation 1, we get E is equal to minus B. From equation 2, we get E, B plus F plus C is equal to minus 27, or since E is equal to minus B, we can write this as minus B square plus F plus C is equal to minus 27. Let us call this equation 5. And from equation 3, we get EC plus FB is equal to 0. Now, since E is equal to minus B, we write minus B into C plus F into B is equal to 0. If you take B common from the two terms on the left hand side, we get B multiplied by F minus C is equal to 0. This implies that either B is equal to 0 or C is equal to F. Let us examine what happens when B is equal to 0, and then we will examine what happens when C is equal to F. Let us call case 1 is when B is equal to 0. Then from equation 5, that is this, we get minus B square plus F plus C is equal to minus 27, and B is equal to 0, so we simply get F plus C is equal to minus 27. And from equation 4, that is this equation 4, we get CF from equation 4 we get CF is equal to 121. Therefore, F is equal to 121 by C. Putting this value of F in this equation, we get F plus C is equal to minus 27, or शब्द का अच्छा भूल है Now Let us examine the cases when b is equal to 0 or when c is equal to f separately. Let us call case 1 as when b is equal to 0. In that case, from equation 5, that is, from this equation, we get minus b square plus f plus c is equal to minus 27, and since b is equal to 0, we simply get f plus c is equal to minus 27. Let us call this equation 6. Then from equation 4, we get Cf is equal to 121. Therefore, f is equal to 121 divided by c. Putting this value of f in equation 6, we get f plus c is equal to minus 27. Therefore, 121 by c plus c is equal to minus 27, or 121 plus c square is equal to minus 27c, and bringing them all of them to one side, we get c square plus 27c plus 121 is equal to 0. This is a quadratic equation in C, and following the general solution to a quadratic equation, we get C is equal to minus 27 plus minus root over 27 square minus 4 into 1 into 121 and whole divided by 2, and that is equal to minus 27 plus minus 27 into 27 is 27 square minus 484 square root of this divided by 2. Now what is 27 square? 27 multiplied by 27 is 54. So 9 to 729. 27 square is 729. Therefore, we get C is equal to minus 27 plus minus 729 minus 484 square root of this divided by 2, and that is equal to minus 27 plus minus square root of 729 minus 484, it becomes 5, 4, 1. So this becomes 145 divided by 2. And we can write it in a further simplified term, that is minus 27 plus minus 145 is 5 into 49. So 49 is the square of 7. So we can write These are 7 square root of 5 whole divided by 2. Now the exact value does not matter. We observe here that C is not an integer. In the question it is mentioned that the coefficients have to be integers. C is also a coefficient and it is not an integer. Therefore, the solution B is equal to 0. This is invalid. Let us now examine the case when we have to find out when f is equal to C, that is when C is equal to f. Now from equation 4 we know that we get C multiplied by f is equal to 121, and because C is equal to f we get C square is equal to f square is equal to 121. Therefore, C is equal to f is equal to 11. Now, that being so, let us put these values of C and f into equation 5, which is this equation. That is minus b square. From equation 5 we get minus b square plus f plus c is equal to minus 27. Putting in the value of f and c, we get minus b square plus f is 11 plus c is 11 is equal to minus 27, or minus b square is equal to minus 27 minus 11 minus 11, and that is equal to minus 49. Therefore, b square is equal to 49 or b is equal to 7. And from equation 1 we know that b plus e is equal to 0. Therefore, e is equal to minus b, and that is equal to minus 7. So, the coefficients are what are the coefficients? Coefficients are a, b, c, d, e and f, and their values are: a is one of the leading coefficients and this is 1, b we have just now found out to be 7, c is equal to 11, d again the other leading coefficient, that is 1, e is minus b and that is minus 7, f is equal to, we have found out as 11. So these are the 6 coefficients, and our quadratic equations were ax square, quadratic expressions rather, ax square plus bx plus c and dx square plus ex plus f. Putting the values of the coefficients, we get x square plus 7x plus 11 as the first quadratic expression, and the second quadratic expression becomes x square minus 7x plus 11. So these are the two quadratic expressions which, when multiplied, will give us x square plus 7x plus 11 multiplied by x square minus 7x plus 11. This, when multiplied together, will give us our given expression, that is x4 minus 27x square plus 121. And we are not only required to find out the two quadratic expressions, we are supposed to find out their sums. So what is their sum? X square plus 7x plus 11 plus x square minus 7x plus 11, and that is equal to 2x square. The 7x and minus 7x will cancel, plus this will be 22. So the result is the sum of the two quadratic expressions whose product give us this expression is 2x square plus 22. This is the. Finally, please like, subscribe, share and hit the bell icon so that you can be immediately notified for new uploads. It is completely free and only takes a few seconds, and you can always unsubscribe later. Thank you.